Hi guys, welcome back to my channel. It's Doc Junel. The subject at hand is FAPN, and for today's discussion, we'll be talking about the physiology of nerve cells. If you're ready, then let's start. Last week, we talked about the different anatomy of the nervous system, and one of the more important terms that we have to review before we move on with today's topic is the axon. Last time we said that the axon's function is to transmit signals away from the cell body. All right? But today, I want to introduce to you the term axonal transport. So right now, our baseline knowledge about the axon is that it has the ability to transmit signals from the cell soma, from the cell body or soma, away, no, papunta sa ibang mga nerves. But when we say axonal transport, it is the transport of substances, including ions, nutrients, and organelles from the cell body to the axon terminal or from the axon terminal to the cell body. And how are they able to do that? How are they able to transport or move substances such as your ions and nutrients and your organelles? It is through the help of your microtubules. If you will go back to our discussion last week, microtubules act as the railroad, allowing the substances to have a pathway for transport. So basically, when we say axonal transport, no, it is the process of transporting organelles and substances from one nerve to another. And again, as mentioned, there can be two directions, no? When we say anterograde, from the soma to the axon terminal, and when we say retrograde, from the axon terminal to the soma. Again, let me reiterate that when we say axonal transport, ang transport natin dito are substances and organelles. Iba pa ito sa ability ng axon to transmit signals. Okay? Iba pa po yun. And axonal transport can occur in two ways, no? As mentioned, meron tayong two directions, anterograde from the cell body papunta ng axon terminal or from the axon terminal papunta ng cell body, and that's what we call retrograde. Now, there are two types of axonal transport. First is slow axonal transport, and the second one is fast axonal transport. When we say slow axonal transport, the movement of substances and organelles only happens around 1 to 5 millimeters per day. If you have a ruler, and if you check it out kung gaano kahaba yung 1 to 5 millimeters, it's really super short, no? And usually the body uses slow axonal transport when there is an injured nerve and the body wants to regenerate or repair that nerve. It uses the transport of axoplasm, no? Specifically the liquid portion of axons. However, as mentioned, kaya hindi nangyayari yung regeneration because the movement of substances are very slow. Usually, it takes months, years, no? Even multiple years bago magkaroon ng complete repair ang isang neuron. So, eventually, because of this slow axonal transport, regeneration becomes impossible. The second type of axonal transport is fast axonal transport. This is the movement of substances at around 200 to 400 millimeters per day. Now look at the difference, no? 200 to 400 millimeters while the other one is 1 to 5 millimeters per day. Malaki yung pagkakaiba nilang dalawa. So basically, fast axonal transport happens because it uses proteins that function as motors to move materials. So basically, when you say fast axonal transport, para kang nakasakay sa sasakyan. Mas mabilis yung biyahe. And when we say slow axonal transport, para kang naglalakad, no? Maikli yung distance that you are able to cover. Now, other than the speed, another difference is their direction. Slow axonal transport usually happens anterograde, while fast axonal transport can occur in both directions. Okay? Now, Why is this important? And what is the factors contributing to the differences, no? Bakit may slow axonal, bakit may fast axonal? This is because there are different types of axons present in the nervous system. There are type A axons or type A fibers, type B, and type C. Let's differentiate them. When we say type A, these are the largest axons, no? Largest meaning yung diameter ng axon mismo. The axon here is the blue thing inside. The diameter of the axon itself is large, no? When it's a B type, medium-sized. And when it's a C type, very, very thin or small yung axon natin. No? Let's take this as an example. This one, no? No, ang nipis-nipis niya. Moreover, one important contributor to the speed and the differences of these fibers is the presence of your myelin. For type A, not only is the axon large, but the axon is myelinated. May myelin na nakabalot doon sa ating axon. Type B is also myelinated, while your type C, as seen in the image, is non-myelinated. Alright? Now, let's talk about the absolute refractory period. Later on, you'll understand the meaning of this term, no? But for now, kailangan lang natin maintindihan na kapag type A fiber, maikli lang yung absolute refractory period nila. Pag type B naman, longer compared to A. At kapag type C naman, it is the longest out of the three types of axons. In terms of speed, type A, being the largest and myelinated, can transport action potentials by 27 to 290 miles per hour. Bilis nun guys, no? 27 to 290 miles per hour. While your type B can transport action potentials at an average of 34 miles per hour. And lastly, your type C, significantly slower at 1 to 4 miles per hour. Now that we know what they can do, where can we find these nerves? No? Where can we find these axons? Your type A can be found in your sensory receptors. Now, where are our sensory receptors? In our skin. What layer of our skin? Our dermis, no? Meron sa dermis, meron sa epidermis, meron din sa hypodermis. But majority of them are in the dermis. So they function for touch, pressure, position, joint temperature, and pain. Basically, kailangan mabilis, kailangan maganda yung quality ng axons natin in our sensory receptors because we need to be able to feel the stimulus, no? And not only that, they are also distributed in our skeletal muscles. Meaning, once we feel the stimulus, the body will be able to react accordingly, immediately, no? So that's where you find your type A fibers. Your type A fibers naman, type B, can be seen in the viscera. When we say viscera, these are the non-voluntary organ systems that we have. So basically, mga organs na we cannot control. Sa type B sila, no? Mga viscera natin. And also your autonomic nervous system. Again, we do not control this. So basically, yung mga di natin makontrol, type B. And then type C, naisip siguro natin, no, where can we find this? Parang very inefficient, parang very ineffective naman tong type C. But it is distributed, as you can see here, they function for pain, touch, pressure, heat, cold. So basically, meron tayong mga type C in our sensory receptors also, no? And their difference from type A is that they carry more of pain. Rather than sensation, it's really pain na dala-dala nila. Moreover, they can also be found in our viscera, no? Similar to your type B. And in terms of motor, they can be found in our autonomic nervous system, similar to your type B. Now, these three major types of axons can further be divided into their subtypes. So you have your A alpha, A beta, A gamma, and A delta. Your B, your C, which also can be found in two places, your dorsal root and your sympathetic places. So when we say A alpha, they function for proprioception. Ang ibig sabihin ng proprioception is position, no? Like let's say somebody touches your right shoulder, no? Hindi ka naman nagde-decide kung saan ka titingin, 'di ba? Kaliwa o kanan. You automatically look to your right. Now, what makes it possible for you to be able to see kung nasan yung position ng stimulus? It is your type A alpha. Their function of proprioception helps us determine position. Your A beta naman functions for touch and pressure. Okay? Touch and pressure, your A beta. Your A delta functions naman for pain. No? So basically, your A alpha, A beta, A delta, puro sensory sila. And then of course, let's not forget that your A can also be found in your skeletal muscles. So that's your A gamma, motor to muscle spindle. Your type B again can be found in your viscera and autonomic. So that's their function. And then your type C, no? As you can see here, they carry most of pain. And they can also be found in our autonomic nervous system. And under the autonomic nervous system is sympathetic. All right? Now further, when we talk about sensory neurons, meron pang subclassification yung mga sensory neurons natin. They are 1A, 1B, 2, 3, and 4. And each number classification of sensory neurons are composed of different fibers as well. No? So as you can see on the right, you have your A alpha, your A beta, A delta, and C. So basically, ganun pa rin naman. Remember that your A alpha functions for proprioception. So nandun sila sa mga muscles natin because they can also be found there and in the Golgi tendon. So basically, ito sensory receptor din yan in the muscle. Oh, what else? Your A beta for touch and pressure. So they're here as well. Your A delta for pain, no, prickling sensation. And then type C also for pain. Right? Now, we will be able to apply that knowledge later on. But for now, we will be talking about quite a complicated topic, but that's really, really important for us to understand this. And this is nerve response. Okay? So, our nerve, no, yung pinaka-outer part ng nerve natin, we call it the cell membrane or the plasma membrane. The plasma membrane acts as a gate that checks what substances are able to enter the nerve and what substances exits the nerve. Now, this plasma membrane or cell membrane makes sure that there are ions inside and ions outside the cell. So, in normal situations, potassium is inside the cell while sodium is outside of the cell. And in order for us to better understand that, I gave here a mnemonic, PISO, potassium in, sodium out. So let's take this picture as an example. You can see here the fluid. This is the outer part of the cell. Sorry, let me just put my pointer there. This is the outer part of the cell, and this is the inner part of the cell. And it is separated by your plasma or cell membrane. So as we said, potassium, there is more potassium inside and there is more sodium outside. As seen in the image, no, there's only one potassium outside here and majority are composed of your sodium, which satisfies this mnemonic of sodium out. And inside the cytosol, we can see more potassium and only one sodium, which again satisfies our mnemonic, which says potassium inside. Now, because of this difference in the distribution of ions, no, it creates a difference in electrical potential. How did that happen? Notice that your ions have charges, no? They are both positive charges, sodium and potassium. Pareho silang positive. But I want you to remember that sodium is more positive compared to your potassium. Okay? Sodium is more positive compared to your potassium. So since there is more sodium outside compared to inside, which is more positive, the outside of the cell or the inside of the cell. Again, if sodium is more positive than potassium and sodium is more abundant outside, then what is more positive? Outside o inside? Siyempre, outside. No? So even if there are potassium inside and even if they are also positively charged, the difference in positive intensity, no, dahil mas intense yung positivity ni sodium, mas nagiging negative yung loob ng cell. Okay? And this difference in electrical potential creates what we call the resting membrane potential. So basically, when we say resting membrane potential or RMP, it is the electrical potential difference across the membrane, no? Across the outer and the inner part of the cell membrane. Now, when we say resting membrane potential, this is the charge of the cell when it is relaxed, when it is not being excited by any stimulus. Okay? And the greater the difference in the amount of sodium and potassium, the greater the RMP. Now, let's go to the numbers so that we can better understand. Outside of the cell, there are 142 milliequivalents per liter of sodium, as compared to inside, which only has 14 milliequivalents per liter. So basically, more sodium outside. While your potassium only has 4 milliequivalents per liter outside compared to your 140 milliequivalents per liter inside. No? So when you look at it, sodium outside is just as equal as your potassium inside. But how come that the net charge inside is negative? Again, because your sodium is more intensely positive compared to your potassium. That is why, given this amount of potassium and sodium inside and outside the cell, we create a resting membrane potential of negative 94 millivolts. Okay? Negative 94 millivolts ang ating RMP in a nerve that is not being stimulated. And what brought about this negative charge? The more intensely positive sodium ions outside. Okay? Now, aside from this unequal distribution of ions outside and inside the cell, what are the other factors that create the resting membrane potential? No? So, as we can see, no, outside or extracellularly, the charge is more positive because there's more sodium. While inside, although may potassium sa loob that is also positively charged, negative yung charge sa loob, as you can see in this image, no? And why is that? Because your sodium is more intensely positive. Other than that, other factors that contribute to the development or formation of your RMP are the inability of anions to leave the cell. When we say anions, these are negatively charged particles. No? So basically, yung mga negatively charged particles inside, they cannot go outside para mas maging positive yung loob. No? Wala siyang capacity to leave the cell. And other than this, there is a pump that is called sodium-potassium ATPase. So anong ginagawa nito ng sodium-potassium ATPase? If this is our nerve, and this is the sodium-potassium ATPase, again, it's a pump. It pulls in, hinihila niya, 2 atoms of potassium, kaya mas maraming potassium sa loob, and it pushes outside 3 atoms of your sodium. Kaya mas maraming sodium outside. Okay? So these are the 3 factors contributing to the development of your RMP. The unequal distribution of ions in the ECF, the inability of anions to leave the cell, and the electrogenic nature of your sodium-potassium ATPase. So now naintindihan na natin yung RMP. Yun yung charge ng cell when there is no stimulus, when there is no excitation happening. Now, we have to understand that nerve cells have a low threshold for excitation, meaning mababaw ang kaligayahan ng mga nerves natin. Just a small stimulus will sometimes be enough to excite the neuron to create an electrical stimulus, no? So, ano ba yung mga pwedeng mag-excite sa nerve natin? This can include your electrical, mechanical, and chemical stimulus, no? And ang mangyayari kapag naka-experience or nakatanggap ang nerve cell ng electrical, mechanical, and chemical stimulus, it can excite the neuron and cause a response that may or may not be propagated to other neurons. So, pwedeng ma-excite ang neuron at idamay niya yung mga katabi niyang neurons para ma-excite din sila. Or pwede rin na siya lang yung ma-excite at wala na siyang ibang idadamay. Other than your electrical, mechanical, and chemical stimulus, other reasons behind the excitation of nerves are the conduction of ions. Okay? So basically, the movement of these ions causes a change in the electrical potential of the cell membrane. So ano ulit yung RMP natin? Negative 94. At kapag nagbago ang amount of sodium outside and the amount of potassium inside, then it can lead to an excitation. Okay? Now, how can this conduction of ion happen? It happens through the help of your ion channels. So, in this image, these are your ion channels, no? They are actually, or they belong to a class of proteins called integral proteins. When we say integral proteins, these are proteins that penetrate your cell or plasma membrane. Again, di ba? The plasma membrane um, prevents prevents ions and substances from moving outside and inside the cell. But now, these ions and substances can travel in and out through the help of your ion channels. Why? Because they form pores in the cell membrane. And once ions are able to enter and exit, then it can mediate a rapid change in the electrical potential across the cell membrane. Now, the ion channels does not just open and close at will. Meron siyang mga certain characteristics kung paano siya gumagana. So, number one, it should be able to recognize specific ions. Just like our houses, we do not open the door to just anybody. We should recognize the people who comes in and the people who goes out of our house, right? So it's the same with our ion channels. Hindi sila basta-basta nagpapapasok. Dapat kilala muna nila kung sino o ano tong mga substances na papasok. Next, they conduct the ions, meaning once they open, they act as a bridge, no, in order to transport the substances from outside to inside or the other way around. And lastly, these ion channels can only function if there is a stimulus. Okay? Pag merong external stimulus, then pwedeng ma-activate ang ating ion channels to open and allow the entry or exit of certain substances. Now, the movement of ions will cause a transient change of membrane electrical potential in a localized membrane. Okay? If there will be the movement of sodium from outside to inside, no? Magkakaroon ng pagbabago doon sa charge because if sodium will come in, then what will happen to the negative 94 millivolts? Sige nga. If sodium will get inside the cell, what will happen to your negative 94 millivolts? It will become less negative. So from negative 94, as your sodium gets inside the cell, magiging negative 84, negative 74, negative 64, and so on. It will become less and less negative until it hits the positive mark. No? Hanggang maging positive siya. Now, once a nerve is excited by a stimulus, whether it be electrical, mechanical, or electrical, mechanical, or chemical stimulus, then there can be two types of responses given by our nerves, no? And what are these two responses? First is a local potential, and the second is an action potential. When we say local potential, these are excitations that do not propagate, meaning yung nerve which was excited will not be able to excite other nerves. That's the meaning of your local potential. And when we say action potential, considered international, no, just to show the contrary, no, to the local potential. Si local potential, andun lang siya sa sarili lang niya. Si action potential, nangangapit bahay, no? It's able to excite the other nerves surrounding it. And usually, the potential of the potential created by your action potentials are usually propagated. Okay? Later on, we'll discuss what's the meaning of hyperpolarizing and depolarizing. Yan. So, there are many different types of local potential, and I want to start with the synaptic potentials. So, if you remember, sabi natin, the axon transports signals from the cell soma away from the body. Now, at the end of your axons, you will find your axon terminal. And your axon terminal will combine or attach to a dendrite on another nerve, as seen in this image, no? You have here the soma, the axon, and then the axon terminal is attached to the dendrite of a second neuron. No, in the hopes na sana pag na-excite siya, ma-excite din niya yung katabi niya. So what will happen? Let's say that this nerve was already stimulated. Na-excite siya. Magpapadala siya ngayon ng synaptic potential along the axon. Pagdating si axon terminal, ito na yung mangyayari. The axon terminal will release neurotransmitters. Neurotransmitters are like chemical messengers, no? So they are like chemical messengers that gets released from your axon terminal. I-release ang neurotransmitters in a space called synaptic cleft, because the combination of your axon terminal and dendrite is called a synapse. So in that small space in between the axon terminal and the dendrite, it will release its neurotransmitters. And the neurotransmitters will attach to the receptors found on your dendrite. Okay? So, ganun ang mangyayari ha. Ma-excite ang ating unang nerve. It will send a signal to the axon terminals. Axon terminal will attach to the dendrite and form a synapse. In that small space between the axon terminal and the dendrite, there is a space called synaptic cleft where the neurotransmitters are released. And these neurotransmitters must be able to attach to the receptors found in the dendrite. All right? So this is what happens in synaptic potentials. Next, we have generator or receptor potentials. Itong mga ito naman, they respond to an external stimuli. Like, let's say, somebody touched you. So, what will happen to the nerve endings, to the nerve receptors found in the skin? They will be deformed. No? Why deformed? Kasi there is pressure, no? There is touch being involved. So, basically, kapag lumubog yun, ma-excite yung neuron. So the deformation of the membrane by an external stimulus will create a generator or receptor potential. What's the difference between generator and receptor potentials? Your generator potential, yung kanyang sensory receptor, is attached to the afferent or sensory neuron. Directly attached. So pag ito na-deform, it will create a signal causing sodium to again enter the cell. So yun pala yung nangyayari pag na-excite yung nerve, no? Pumapasok ang sodium inside the cell. So from yung labas, more positive, at yung loob, more negative, nagbabaliktad. The inside of the nerve becomes more positive, and yung labas ang nagiging negative. So that's your generator potential. Basically, magkadugtong yung sensory receptor and your afferent or sensory nerve. When we say receptor potential naman, as you can see in this image, detached silang dalawa, hindi sila magkadugtong. Pero same pa rin yung principle dito, no? It still has to be deformed And once it is deformed, pag na-feel na niya yung pressure or touch, it will send um, chemical messengers again. Magsisend siya ng chemical messengers papunta doon sa ating sensory neuron. Okay? That's what happens for a generator and receptor potential. And lastly, we have your electrotonic potentials. These are stimulus from an externally applied voltage at isasubject nila yung mga na-harvest nila na nerves under electrotonic potentials. Now, this local potentials that we have talked about, yung synaptic, generator or receptor, and even yung electrotonic, they share common characteristics. And first, that we have to understand about local potentials is that they are graded. What do we mean by that? It means that the degree of deviation in the resting membrane potential will depend on the strength of the stimulus. So as mentioned, no, if there is a stimulus and the nerve will be excited, sodium will enter the cell and cause the inside to become more positive while the outside of the nerve becomes more negative. So, yung degree ng pagbabago sa charge no from negative 94, kung paano yung bawas from negative 94, it will depend on the strength of the stimulus. So if you have a small stimulus, there will be a small change in voltage. But if you have a large stimulus, then malaki rin yung pagbabago sa voltahe. As you can see in this image, no, you have three stimuli here. Stimulus 1, from negative 70, it was able to, I think, elevate the voltage to around negative 75. No? Fair enough. Then you gave stimulus number 2. Ito mukhang umabot na siya ng around 60 or 59. No? Sorry, yeah. 60 or around, ano pala. Yeah, tama. And then if you give a bigger stimuli, then mas tataas pa siya lalo. Mas magiging less negative siya. So the stronger the stimulus, the greater the difference in RMP. Next characteristic of all local potentials is if it wants to propagate the signal, if it wants to be able to excite fellow neurons, then it must apply summation. And there are two types of summation. When we say temporal summation, stimulus is given consequently, sunod-sunod. No, they come one after the other to produce a larger stimulus. That's your temporal summation. But when we say spatial summation, it refers to two stimulus acting on a single cell. So let's look at the images. First is your temporal summation. No? Isa lang yung axon terminal that is attached to the cell body. At yung nag-iisang axon terminal na yon will fire continuously. Sunod-sunod siya magpapadala ng signal, ng local potential in the hopes na sana mag-propagate eventually yung kine-create niyang potential. When we say spatial summation, iisang nerve lang yan kailangan i-excite pero ang dami ng axon terminals na tumutulong. So it refers to two stimulus acting on the same cell at the same time. Okay? So para ma-propagate, baka kailangan ng nerves natin mag-participate sa summation. And lastly, they are short, meaning they do not spread throughout the cell, and their local potentials, bakit hindi nagiging action potentials? Because they eventually die out. And why do they die out? Bakit nawawala yung charges according to the slide? Because of the presence of leak channels. May mga tagas. So even if the cell is able to bring sodium inside, no, to make it more positive, sometimes there are leak channels present which allow the escape of your sodium outside. So nakakatakas sila. Imbes na gawin nilang more positive yung loob ng cell, tumatakas sila. So nababawasan yung pagiging positive ng soma. No? So usually, mga local potentials natin, they are only effective for short distance communication only. But you do not expect mga local potentials to happen in the really crucial parts of the body. Now, since we're done talking about local potential, what's the counterpart of this one? The one that is international per se, that is your action potential. So, similar lang naman yung, yung principle. There should be a change in the electric potential spreading along the nerve. Okay, so ano yung normal ulit natin na voltage? Negative 94. Negative 94 RMP or resting membrane potential. Now, kapag bigla nagbago yung charge from negative 94, then you can call it an action potential. And ang kakaiba sa action potential, it can propagate to other nerves. Yan na, pwede na siyang makahawa. Okay? And unlike your local potential na eventually nagda-die out yung signal because of leak channels, sa action potential walang leak channels. Okay? Walang makakatakas. Kaya kapag na-excite ang cell, automatic yan. Mangyayari yung reaction na hinahanap natin. Now, action potential will occur when yung pagbabawas ng negative or what we call the depolarization reaches the threshold of negative 65. So as you can see in this image, no, ito yung negative 90 natin na RMP and then negative 65 is the threshold. And all of the efforts from negative 94, yung effort mo na binibigay para umabot siya ng negative 65, no? Yan yung local potential mo. The effort for it to reach negative 65. Okay? And usually, ang action potentials natin, mayroon yung all or none principle. Pag in-excite mo ang isang nerve, it's either magkakaroon ng action potential or none at all. Yun yung ibig sabihin na to ng all or none principle. Kapag nagbigay ka ng stimulus, it's either mabubuo ang action potential o hindi. Yun lang siya. Walang consider na mahinang action potential. Okay? So, lahat ng action potential, pantay-pantay yan in strength. Now, look at this. An action potential will not respond to a sub-threshold stimulus. Meaning, kapag ang isang nerve ay stimulate mo using a sub-threshold, meaning ng sub-threshold below the threshold, no? Hindi ka aabot sa negative 65, walang mangyayari. You will remain as a local potential. Okay? But, when you give it a threshold stimulus, pag sinabing threshold stimulus, enough to cause it to reach negative 65, and once the electricity reaches negative 65, pag enough na yung sodium na pumasok, then automatically, it will create an action potential. Diba? All or none. Aabot o hindi. Pag umabot, yan, magkakaroon ng action potential. Pag hindi umabot ng negative 65, walang action potential. Kahit negative 64 pa yan, di ba? Isa na lang yung kulang, hindi pa pinagbigyan, no? Hindi talaga mangyayari. Okay? So just remember guys that the response to a supra-threshold amplitude is the same as the result in a threshold amplitude. Meaning, di ba sabi natin sa threshold, ang goal lang from your resting membrane potential, maabot niya yung threshold natin of negative 65. So, yun lang yung goal ng threshold stimulus. Pag nagbigay ka ng supra-threshold stimulus, hindi ibig sabihin nun na mas malaking action potential yung makikreate mo. Same lang. The response to a supra will be the same as the threshold. Okay? Now, we are now going to talk about the phases of action potential. Okay? So, there are 4 important phases, namely, resting phase, depolarization, repolarization, and hyperpolarization. So, isa-isahin natin to. When we say resting stage, ito basically yung resting membrane potential natin kanina. No? So, it's negative 94 millivolts. There is no excitation. So, all the ion channels are closed, both for sodium and potassium. And as mentioned, may mga small amount of leakages that happens. Okay? Small amount of potassium leaks out. and a small amount of sodium enters the cell, but it's not enough to cause excitation. So what happens, no? This is the ion channel for sodium. At kita mo naman, sarado pa yung gate na to. And then, this is the ion channel for potassium. Mas maraming potassium inside. Kaya, kaso nakasara pa siya. So, hindi rin makalabas yung ating potassium. And because of that difference in the concentration, it creates the resting membrane potential of -94 to be exact. So, that's the resting stage. Now, once we enter depolarization stage, ang ibig sabihin nito, yung local potential mo was enough to elevate that voltage from -94 to -65. Okay? Yan ang ibig sabihin ng depolarization. Nagtagumpay ka na from local potential, umabot ka ng -65. And once umabot ka ng -65, guys, what will happen? The opening of voltage-gated sodium channels. Ano ba ibig sabihin ng voltage-gated sodium channels? Nakadepend yung sodium channel sa voltage na meron ng isang nerve. Kaya inaaral natin yung mga millivolts. No po? Yan. So, once it reaches -65, the sodium channels will open and there will be increased sodium permeability. And because sodium can now enter the cell, there will be a reversal of membrane potential. Okay? Magkakaroon ng pagbabago doon sa takbo ng ating cell. So basically, mag-o-open yung sodium gate natin, papasok ang sodium from the outside. Pag dumami ang sodium sa loob, no, yung tinatawag natin na sodium influx, pag dumami ang sodium sa loob, anong magiging charge ng loob? Kanina, nung walang excitation, sabi natin -94. Pero kapag may excitation na po, no? Anong mangyayari? Magiging positive siya. From -94 to 0, from 0 to +35 as seen in the image, no? So aabot ka ng until above 0, until +35. Yan ang iyong depolarization. At anong responsable sa depolarization? The opening of voltage-gated sodium channels. Okay? So that's the goal of depolarization, to raise up the difference in potential from -65 to 0. Ngayon, sabi natin, di ba, kailangan aabot siya ng 35 para magkaroon ng action potential. So, more voltage-gated channels will open until the interior of the cell becomes less negative. Okay? So, kailangan mas maging less negative yung loob. Kita nyo naman dito, from -90 to +35. Ibig sabihin, no, naging less negative siya. Di ba? And once it goes beyond 0, we call it the reversal of polarity. Sabi natin, di ba kanina, aangat yung charge kasi there's more sodium coming in. Right? And we call that the reverse. So, oras na lumagpas na ng 0, yung charge ng ating cell, then we call that an overshoot. Okay? Yung pag-angat niya from 0 to positive, we now call that an overshoot. So, the next stage is repolarization. So, what happens in repolarization? So, naabot na niya yung peak, no, which is +35. Nag-overshoot na. What will happen next? The voltage-gated sodium channels will close. So, hindi na makakapasok ngayon ng sodium sa loob. Moreover, there will be increased potassium permeability. Ano ibig sabihin nun? Magbubukas ang voltage-gated potassium channels. And what will happen? Potassium will start to travel outside the cell. So, wala nang sodium nakakapasok, lalabas pa yung potassium mo. What happens? The cell interior becomes less positive. So, from +35, sinara mo ang sodium channels, binuksan mo ang potassium channels, bababa ngayon yung charge, no? From +35, magiging negative na siya ulit. Kasi, your potassium is continually going out. That is the meaning of your repolarization. The returning to your negatively charged cell membrane. Now, this is what happens, no? Sasara ang sodium channel and then mag-open ang potassium channels natin. And then the last stage of the action potential is called hyperpolarization. So what happens? Pag sinabing hyperpolarization, lumagpas na ng RMP. Our RMP is negative 94. But look at this, no? It's way below that negative 94. And why is that? What happens? Bakit sobrang bagsak naman? It is because the voltage-gated sodium channels remain open kahit na na-reach na yung RMP. So they remain open even if nasa resting membrane potential na, leading to a more negative charge compared to your resting membrane potential. Okay? And after hyperpolarization, there will be continuous opening of your sodium channels until eventually magsara siya at makabalik yung charge ng cell natin towards the resting membrane potential. So putting everything together, this is how it would look like, no? So here, wag nyo na lang pansin yung numbers, dapat ito negative 94, no? Pero dito sa example, ginamit nila 70. But for us, RMP is negative 94 and then threshold is negative 65. So, kunyari ito, no, this is your RMP. Tapos, naka-receive yung nerve natin ng electrical, mechanical, chemical stimulus. So, there will be a local potential, whether it be synaptic, generator, or receptor potential, o kaya electrotonic potential. So, sabi natin, yung mga local potentials natin, graded, they can do summation, and usually short. Pero pag naging effective yung stimulus, no, at umabot ng threshold natin, let's say negative 65, then action potential will happen. So, first, there will be depolarization, the opening of your sodium channels. So, sodium, which is intensely positive, will enter the cell, making the charge from negative 94 become more and more positive. At pag lumagpas ng 0, tawag natin doon overshoot until it reaches positive 35. It will then be followed by your repolarization, which is the closure of sodium channels and the opening of your potassium channels. So from positive 35, it will now become more and more negative. Actually, even if it reaches your RMP, the potassium channels will remain open, leading to the hyperpolarization. And once the potassium channels close, it will be able to go back to your resting membrane potential. Okay? Now, earlier, may nabanggit tayong term when we studied type A, type B, and type C fibers, no? Yun yung absolute refractory period. And what do we mean by that? This is the inability of the nerve to fire a second action potential no matter how strongly it is stimulated. Okay? Kahit gaano pa kalakas yung mechanical, electrical, or chemical stimulus na ibigay mo, pag nasa absolute refractory period ka, walang action potential na mangyayari. There will be no response. And yung period of absolute refractory period starts from depolarization until the first 1/3 of repolarization. Yeah. So at this point, no action potential will be created. Okay, that's your absolute refractory period. At sabi natin kanina, yung type A fibers natin, brief lang yung absolute refractory period nila. While your type C, longest, no? Kaya yung type C, ang bagal-bagal niya kasi hindi siya kayang makapagbigay ng action potential ng sunod-sunod. Okay? So, the next here is your relative refractory period. So, nagsisimula naman yan from the second, third, until yung dulo ng hyperpolarization mo. And during the time of relative refractory period, the neuron will be able to fire another action potential if a stronger stimulus is elicited. So sometimes, kahit wala pang hyperpolarization, pag naka-receive, let's say at this point, pag naka-receive ng strong stimulus, gagawa ulit yan ng action potential. At kahit mas malakas pa yung ma-receive niya, pantay lang yung resulta ng action potential niya. Same lang yung result sa threshold and supra-threshold stimulus. Diba? Sabi natin kanina. Now, anong mga factors ba yung nagko-contribute sa effectiveness ng stimulus natin? Of course, yung lakas ng stimulus. As mentioned, there are threshold stimulus. Ito yung mga stimulus natin that is able to cause excitation. Enough siya to reach the threshold of -65. When we say sub-threshold, not enough naman ito to cause action potential, no? Hindi umaabot ng -65. And when we say supra-threshold, ito naman yung mga greater ang kaya nilang ibigay. However, same lang naman yung result, di ba? Second factor that determines the effectiveness of your stimuli is the rate of rising intensity of the stimulus. Meaning, kapag patuloy kang nagbigay ng subthreshold stimulus sa isang nerve at ang tagal ng interval bago mo taasan yung intensity ng stimulus mo, eventually, wala nang magiging effect kahit taasan mo pa yung intensity. Why? Kasi natututo ang nerve to accommodate. What is the meaning of accommodation? It is getting used to the stimulus and not getting excited anymore. Okay? So basically, because let's say ang intensity mo is 5 at nasanay na yung nerve sa intensity of 5, eventually, wala na lang sa kanya yung intensity of 5. 'Di ba? At kahit itaas mo pa yan ng 6, ng 7, kung mabagal naman yung interval or matagal yung interval, wala pong mangyayaring excitation. But if the intensity is applied rapidly, pag mas mabilis yung o mas mataas yung pag-rise ng intensity, then accommodation will not be observed and action potential could be developed. Next is the strength duration curve. So the strength duration curve is a curve that studies the relationship between the intensity of the stimulus and the time of application to the nerve to give a response. And later on, we'll define these two terms. So let me show you this curve first. Ayan. So the x-axis, for a while. So the x-axis is represented by your stimulus duration or yung time na binibigay natin, no? While your y-axis represents your stimulus strength. So the higher that we go, the greater strength of the stimulus. And the longer that we go, sabihin nun mas mahaba yung oras na kailangan nating ibigay. Now, as we can see here in the curve, habang bumababa yung strength, kailangan mo rin ng mas mahabang time to cause action potential. So, kita natin kunyari ito. If you will give a stimulus this high, you will only need this amount of time to cause an action potential. But if you will give a strength na ganito lang kalakas, you will need more time to cause an action potential, no? So as you decrease the strength, the duration of the stimulus will increase. Okay? So the higher the strength, the shorter time it takes to get a response. And the lower the strength, the longer time it will take to produce a response. So the minimal amount, ito na, the minimal amount of strength that you need to elicit a response is called Rio base. No? Rio base. The minimum amount of strength ng stimulus na kailangan mo to produce a response is called Rio base. So let's say ito yung minimum level, no? Itong dotted green line natin. If this is the minimum level of strength that you need to cause a response, then if you double the strength of Rio base, iikli yung oras, di ba? And that shortened time to get a response to double the Rio base is called chronaxy. Ulitin natin. Chronaxy is the amount of time you need to get a response if you double the strength of your Rio base. Okay? So, anong application na to? This means that no matter how long you stimulate a nerve, if the strength of the stimulus is below Rio base, it will not generate an action potential. And if the stimulus na binibigay mo sa nerve is just at exactly Rio base, it will take a long time before you get a response. Pero kung doblehin mo yung Rio base mo, you will be able to get your chronaxy, and that is a shorter amount of time, no, to get a response. So basically, there are other factors that affect the excitability of the nerve, no? Mas nai-increase daw yung excitability kapag higher ang temperature. If you put a chemical called veratidine, because what veratidine will do is to increase sodium permeability. If you decrease calcium concentration, if you increase potassium extracellularly, and if you take in mga alkaline products, increase excitability. But if you lower temperature, or if you are bitten by a snake na merong tetrodotoxin, what will happen? Madidecrease yung sodium permeability. So pag walang action potential, wala ring action ng muscles. Kasi yung action potential, yan na nagpapagalaw, di ba? Doon dumadalo yung information. So what will happen to these patients? They will be paralyzed, no? If you decrease potassium extracellularly, or if the patient undergoes acidosis, if there is mechanical pressure or decreased blood supply, then madidecrease ang excitability. Now, if we apply itong mga natutunan natin ngayon about action potential, and then yung mga nerves na inaral natin kanina, then we'll be able to understand saltatory conduction. Sabi natin, di ba, myelinated axons are able to transmit signals faster compared to unmyelinated fibers. And why is that? Because, again, let's define muna. Saltatory conduction is the jumping of action potential from one node of Ranvier to another, which causes a faster transmission of action potential to other neurons. So first, we have to understand that action potentials or depolarization cannot occur in the myelinated parts. So dito, tsaka dito, hindi pwedeng dumaloy dyan ang action potential at hindi rin pwedeng magbago ang charge ng areas na yan. So Doc, kung hindi pwedeng dumaloy doon ang kuryente, hindi pwedeng dumaloy doon ang action potential, why did it become faster? Because the electrical current, the ions such as sodium and potassium, can actually flow through the fluid formed by myelin, causing just the unmyelinated parts of the axon needing depolarization. Okay? Sa isang unmyelinated fiber, lahat buong haba ng axon kailangan ma-depolarized. But because of the myelin, hindi mo na kailangan i-depolarize yung buong yan. Dadaloy na lang yung ions and substances sa fluid part ng myelin mo, and then ang kailangan mong i-depolarize is the next unmyelinated part or the node of Ranvier. And because of that, meron parang seemingly jumping appearance ng signal. So I think you'll be able to better appreciate it here, no? Hindi mo na kailangan i-depolarize yung buong haba ng axon mo. Ang i-depolarize mo na lang yung mga unmyelinated parts. Unlike dito, buong axon you have to depolarize, kaya ang tagal-tagal. So saltatory conduction increases the transmission of signals by 100 times. And not only that, but it conserves energy. Kasi syempre, hindi na napapagod yung nerve mo to depolarize the entire axon. So because of that, nakaka-save siya ng energy niya. No? So, because of that, your type A fibers are faster, no, compared to your type C, at mas maaasahan sila in areas such as your sensory receptors and your muscles. So that's it for our discussion. Hopefully you were able to learn something. God bless you and shalom.